Hello and welcome back. A few months ago I bought one of these. It's a ZX Spectrum. Now I had one of these growing up, so there's a lot of nostalgia attached to it. Now at the time I did an unboxing video, but I also had to mod it in a couple of ways, fix it up to get it working, and I had a little bit of a play with it. Now since then I've done a couple of videos on my extras channel to recap it and replace the power regulator, just to kind of make the system a little bit more stable for the long term. But I have said I want to spend some time looking at this expansion port, so that's what I'm going to do today. Let's take a look. Okay, I remember being fascinated by this expansion port when I was younger, because it looks terribly mysterious and I never had anything that plugged in there. I did see some of the things in magazines and in the shops though, and since the last video I've managed to get one. So this is a ZX Interface 2. It's a very basic circuit I believe, but it's got two joystick ports, it's got outputs for the ZX printer, and it's got this cartridge port. I never had a ZX Interface 2, they weren't actually that common I don't think, and the cartridges that fit in here were incredibly rare. So the cartridge port is a very short edge connector in here. Now I do know that in some consoles the cartridge port was very flexible, like on the SNES they managed to fit coprocessors and extra memory and all kinds of stuff like that onto the cartridges. But on the Spectrum this cartridge port is absolutely minimal. It's basically the pins that you need to interface a single 16 kilobyte ROM to the system. All the lines on this port are direct mappings to a subset of lines on the main expansion port, so this is actually a good place to start to try and gain an understanding of that expansion port. So what I want to do is build a breakout circuit that is going to allow us to both explore the signals and also interface something to here, because I think that's actually going to help us gain a better understanding of the Spectrum. Let's design a PCB. I found this symbol, which should be the correct pinout for the Rom cartridge. There's something familiar about the order of these address lines. It does look like it matches a ROM chip, which makes a lot of sense. The data lines as well. Okay, that's all the wires connected up. Now I'm interested in another part, but let's firstly break out these header lines. So these are the headers I need to create a breakout. But what I'd like to do is also add a ROM chip onto this board that we can do some experimentation with without having to bring all of the lines out. A14 is a special case because we don't actually want to wire A14 here to the chip, because this ROM is 32 kilobytes and this ROM socket only supports 16 kilobytes. So these headers give us access to all the lines to probe and get an understanding of. And then this ROM socket and these lines that will go on another header, they give us an easy way to put the bulk of these connections across to a ROM chip and then experiment with it to see how we get the hookups to work. Now, that doesn't look like these pads are very well centered on the grid spacing. Now, inside the interface 2, it is a open-ended connector at each end. There's not a lot of documentation that says how far we're supposed to go each side. Okay, I don't think this header's 2.54mm. In theory, everything apart from these top two connectors should be absolutely trivial to route. I think that's done apart from the routing. Knew that was going to be trivial for the auto router. Let's get ground fill in as well. That should be a fun little board. Pretty much exactly what we expected. I've got the ZX Interface 2 here, and that does fit. We're not going to be able to pull the ROM in or out with it in place, but we should be able to get at the other connections. Now, I strongly suspect these caps aren't necessary, but I just wouldn't be comfortable putting a chip onto a PCB without some decoupling. It's going to be a tight squeeze once it's got a chip on it. We may have to take this out the box to get it to work right. Should have made this a bit longer. Let's solder this up. I could take this out the case for now, but I want to work out a solution to that problem in the future. Right, well, we've got a workable test board. Not spotting the profile issue there was slightly foolish. Let's see what we can do about that. Okay, now I've managed to get the Jetpack game I showed. I've got a ROM image for it and I've blown it onto this ROM with my ROM programmer. So plugging the ROM in there should connect up all the common cables, so basically address and data. And now we need to worry about the signals we've got from the cartridge here and the ROM here, necessary to make this act like an actual ROM cartridge. That does not fit in there, and I don't think it goes in far enough to make contact. That was a bit of a dumb mistake, but we can get around that easy enough. So this is a totally custom chip that's used to interface the joystick ports. And I believe every wire on here just connects direct to one of the wires on the expansion port. And of course, this plugs in nice and easily there. Right. Let's connect up a DuPont cable for that. Now I don't have another 6-wire DuPont cable, but we've got ground and then power here, so we don't need that. We can just get away with a 4-wire one. Let's get a bit of breadboard out. Now I think we should start by just trying to make the Sinclair work with this cartridge plugged in. Let's grab the power. Next line was the address 14 line on the ROM. Now I'm going to take that low. I'm not going to be using it for now, but that's a 32K ROM and I put the game into the lower 16K, so we want that to be a 0. And we've got the right enable line, that's active low, so we'll just pull that up. And then we've got a couple of more complex ones. We've got the output enable and the chip select line. Those are ones we're going to have to do something more interesting with. But for now, let's just disable those. They're active low, so let's pull them high. So here we've got, well, we've not brought the power and ground lines across. We've got memory request, ROM chip select, and then address 15 and address 14. We can ignore the address lines. We can ignore memory request, those are outputs, but ROM chip select is an interesting one. Now what I believe that does is that's actually the chip select line on the 16K ROM chip on the Spectrum motherboard. So that's got a pull down on it. So if we don't do anything with that line, that ROM chip will sit there in that first 16K of memory. But if we were to pull it high, that disables the chip and basically leaves a 16 kilobyte hole in memory for the ROM chip here to fill in. But without touching any of these wires, this should leave the Spectrum operating completely in its factory default state. Let's give that a try. I've got my composite capture card plugged into the PC at the moment, so this will save us a little bit of desk space. Okay, that looks good. Right, so let's pull that ROM chip select line high, and we expect this to stop working. That's because the system, when it switches on, will start trying to read data from that ROM in the bottom 16K, and of course nothing's going to be pushing data onto the bus now. Well, that's definitely going wrong, which is kind of what we would expect. So now we have to see if we can make the ROM chip sit in that 16K region. Now we've got output enable and chip select, which if they were both low, we'd be pushing our data onto the bus for whatever address was there. But incoming, we've got memory request and 2 address lines. Now 16K is the first 2. Now for the first 16K, those 2 lines are going to be low, and we want to see memory request low as well. So to output, we've got 2 lines we need low, but we've got 3 lines that all need to be low before we output. So we're going to need to combine these. I'm going to use a 74LS32 OR gate chip. these breadboards, they don't entirely line up between the power rails and these bits, which is kind of confusing me slightly. There's the power and ground. Now we only need one OR gate at the moment, so I'm going to bring the AVR inputs low. This strictly isn't necessary on this range of chips, but people always complain in the comments if I leave any inputs floating. Now we in theory can do this either way, but just because of the way that we're used to using chip select lines, I think I will use that. So chip select on our ROM chip will be active low when both of the inputs are 0. So then the output enable line will take to that memory request. So in theory our ROM chip should now occupy the bottom 16 kilobytes of memory. And if I've done that right, and that ROM image is correct, this should work. And it doesn't. Okay, so we've got power and ground right. All of those inputs should be fine. Those are the 2 address lines. So address 14 is low, write enable is high. Output enable comes from memory request. Okay, I guess it's time to fire up the oscilloscope. That line looks okay. Let's look at that combined chip select line. Before I explore the circuit anymore, I'm going to double check the ROM image on here. Should have made one with a ZIF socket. Hey, that's what we wanted to see. Let's turn the scope off for now. Alright, now I played this with the keyboard last time. Such fond memories of this game. I'm not even sure I've ever played this with a joystick, but select it like that and then start. Awesome. Now, every other time I've played this game in my life, I've had to wait through the whole kind of Spectrum tape loading process, but there I just get to load it instantly through the cartridge. I was hoping to start this video off demonstrating with a cartridge just to show you what this device did, but they're really difficult to get hold of and I got outbid a couple of times on eBay for them. So the fact that we've managed to assemble this, get it working, and even do a little bit of early experimentation with some of these lines, I think it's really cool. I think it's time to tell you one of my long-term goals for working on the Spectrum. Okay, so there is an incredibly simple set of lines coming out of the cartridge socket, and the more complex things, such as what was done on the SNES to allow coprocessors and additional graphics support to be added to the system, that's just not possible on the Spectrum, or at least that's the traditional belief. You've only really got the wires necessary to fit a ROM in. Now, some enterprising people have managed to extend the system very slightly by creating custom triggers to allow to switch in multiple banks from a larger ROM. But something that what I would like to do, I'd like to see if it's possible, is to construct a system that allows us to integrate a coprocessor of some kind, just to add functionality to the Spectrum. I think it would be a really fun experience to try and experiment with that. We're going to need to understand some of these signals a lot more. We're going to need to be able to predict the behavior of some of them. But that's part of the reason why I'm plugging this in, because I like to explore with this kind of circuitry. I think this step is done. I'm probably going to make a new version of this board which I can plug direct into here and maybe make some of these cross connections already. To make a coprocessor, we need to be able to map some memory in, and the system's already designed well for that. But then we need to set up a dynamic channel of communications to the coprocessor and back to the Spectrum. And then we can put in a ROM with a piece of code, and once we've got that working, we can use that process to transfer data across from a larger pool of memory. It'll be quite a fun bit of experimentation. This is just going to be a little background project for me. It's probably going to take a while, and you'll probably see the next video in trying to decode all of this next time I'm waiting for some parts or PCBs. But I hope you found this interesting. I really enjoyed that. It's the first time I've ever played a game on a Spectrum that loaded instantly off a cartridge. They were really rare growing up, and I didn't get a chance to work with one. As always, thanks to my patrons. I really appreciate the support. Now, this project is a little bit of a side quest from my regular kind of CPU and peripheral component videos, but I hope you can see that what I'm really doing here is just exploring the way some of these systems were put together, applying some of the knowledge we've learned, and maybe we might pick up a few things to bring back to the CPU series along the way. So I hope you found it interesting, and I will see you again soon. Goodbye. Okay, this is more difficult than the keyboard, or at least I'm more used to the keyboard. Okay, I think that little green thing's a pick up for points, but I don't need to get it. Awesome.